So this is a demo video of our project. Our project is MEDCHAIN. So we will be walking you through the different modules and the objectives and all the theories behind our project. So first of all, the main objective behind this project is to develop a better and secure personal health records management system using blockchain. As we have done some research, we could find that the existing medical system is not performing as it's supposed to be, as we all know that medical records are very vital information about an individual, and there has been a lot of cases of breaches or tampering with the medical records. So uh, we are trying to develop a better and secure personal health records management system using blockchain. So this is a simple graph which shows the different medical records errors that has happened throughout the country. There has been a lot of tamperings and errors which has happened within medications and prescriptions, or results in lab and test results, or personal info and medical history. So from this graph it is very clear that the existing system has a lot of drawbacks and there are a lot of errors happening. So to list upon the issues with the existing system, there are two main issues. One is of course the security issues. There has been issues of breaches and tamperings of medical records, leakage of data, manipulation of medical records, medical data of patients. The other major flaw with the medical record system as of now is that if I have to shift my treatment from one hospital to another hospital, I cannot simply move my records from one hospital to another, because the authority or the full accessibility over my record lies within the hospital. So when I have to shift my treatment from one hospital to the next hospital, I have to start a new medical record in that hospital. So what happens is that my medical records will be scattered across different hospitals and different medical authorities. So we are trying to combine all the medical records and integrate it into as a single medical record, and we are also trying to improve the security issues. Apart from that, we just did a survey. We just asked simple questions such as, are you satisfied with the current health record system? Have you ever been denied access to your own health records? Do you prefer to view your medical records in a single platform? Do you trust hospitals regarding the safekeeping of your health records? We shared these questions as a Google form to people across various age group, and from these results it is very evident that people actually require a better medical records management system. So we decided to proceed with our project. So how we are planning to implement the project is using a blockchain network. The traditional system were using client server architectures or centralized databases, where everything or the full authority or the full control over the medical records lies within the organization. So we cannot, if organization makes some changes on any records, we cannot see that, or we cannot prove that or anything. So the reasons we selected a blockchain network is because it is a decentralized network which is immutable and tamper proof. So the transactions or the changes cannot be made directly in the blockchain network. It will be evident. It gives individuals predominant access over the data. It also helps to solve the scattering problem of medical records. It will bring all the medical records together under one platform. It enables to move to a new hospital without having to create a new health record. Also, it gives patients the predominant access over their data. So if somebody wants to see their data, it cannot be done without the permission of patient. Patient decides who views his data or who does anything with his data. So it improves the data security and transparency.
Now let us look at the architecture of the proposed blockchain network. Mainly in our system there are 6 players. They are the patients, doctors, hospitals, governing authorities, pharmacies, and the insurance. All these are connected by the database of chain database as well as the blockchain database. Now let us look at the players and their roles in detail. The first player is the patient. The patient is when a patient visits the hospital, uh, he gave the access to his doctor for adding his health record update on his health record. After updating that, the access has been revoked. Then the next player is the doctor. The doctor requests the patient for the access on his health record. After making the necessary changes, the patient will revoke this access, and the prescriptions data has been added to the blockchain network. The hospital is the one who controls the doctor and patient. The hospital can add records of a patient with his consent, as well as he can verify, as well as the institution can verify doctors. And the fourth player is the pharmacy. After consulting the doctor, the patient visits the pharmacy, and then he gives access the pharmacy to look upon his data. Then after giving the necessary medicines, he can revoke the access to the pharmacy. And we have also added an insurance for proper claim of rightful patients is to be ensured. And the final player is the governing authority. This governing medical authority is added to ensure that there is no manipulation occur internally, so that the whole system is being monitored by this governing medical authority.
Coming to the user interface part of our project, first of all we have a registration form. So let's do a sample registration here. And here we have to provide the health reference number by which the user is being identified by the governing authority. So the registration is done there. So now we log in using the same email ID and the password that we provided. When the password and the username is correct, we are redirected to the dashboard of the patient. Here we can see the username. The user has logged in using the name4. So the different options available in the dashboard are the consultation, pharmacy, insurance, and the help. Here we also can see a recent medical history tab as well. So once the patient visits the hospital, he or she can select this option to visit the doctors, where they are able to enter the doctor ID which they will be provided with once they visit the hospital. So I am entering a sample ID here. This doctor ID is already been in the database when the doctor registers in the same system. So once this is submitted, we can see a message as success. So once the patient has entered the doctor ID, now the doctor can log in into his dashboard, which is shown here. Okay, so once the doctor logs into the doctor dashboard, they can view, they have an option to check the patient request. So once, here we have the request from the patient named name4, and we have the options to accept and reject it. So if the doctor accepts it, the doctor is redirected back to the dashboard, and the doctor can add prescriptions now. When we open this prescriptions tab, we can select the date and we can add the necessary prescriptions are noted here. As a sample, I am adding prescription 1. So on clicking submit, we are again redirected back to the login to the dashboard page of the doctor. So now what happens is the prescription that the doctor now has given is reflected, the changes reflected in the pharmacy tab of the user, the patient who visit the hospital. So here we can see the prescription. It is shown in a text box that is not editable, so If the patient clicks proceed here, we can see the message that the prescriptions have been forwarded and the dispensing process will take place now. So this is the process that actually happens in the front end of our project. The place where the blockchain network comes into play is that when the doctor enters the prescription, this prescription will be forwarded to the blockchain network and it will be stored there. The details and the working of the blockchain part, the backend part of our project, will be now explained.
Now let me take you through all the configurations and settings and structures of our backend network. In this shell script, we generate our crypto artifacts for our organization. We generate the system genesis block as well as our channel configuration blocks here. Next, moving on to the configuration file. As you already seen in the architecture, our organization which has the MSP as the government authority, and in this file we generally assign the signature type and the domain. Next, moving on to the crypto config files. This generally defines our peered organization structures and the specs. And peered organization has the functionality to manage the peers which are under them. In our case, the hospital acts as a generic peer which also has subsections of each organization organized hospitals, and the peers under them are doctors and patients. This is just an example of the connection of the organization, first organized peered organization, which is in our case a subdomain of our larger hospital network. Here we also save the certificates which are provided by our certificate authorities. This is just an example for our block which is already stored in our blockchain network. In our case, the key is displayed here, and the cost of each patient's visit is stored as individual key file, and we can't delete this file, so we also enable the false parameter for this. The values are also stored in the JSON structured manner. This is general structure of our Genesis blocks, and as you can see, all the peers, organization, membership service providers, and their relationships and the hierarchy are generally seen here. Next, moving on to our MEDCHAIN smart contract. As we have already designed the MEDCHAIN smart contract. We have the structures of the smart contract defined here, and the reasons and the generic record sizes. And for example, here the generic records are stored here, and we also define the block size, the transaction rate, and the time delay or the sleep for each transaction applied there. This is our generic app that we are configured here. Here we can also see we use MongoDB and CouchDB as our databases. In this case, MongoDB is the part where we use the off-chain data stored, and the CouchDB we use all the in-chain data. This represents the Docker Compose file where we use containerization for our project, where where in each container we use different organization and peers to test out our network. In this case, each container has a database, that is our CouchDB, which is configured with each of the files or the functionalities which should be run on the background. The first one was the Hyperledger Fabric, and moving on, we also have our each and every patient organizations and doctors running on each and every nodes and containers here. As you have seen, those are our very user-friendly front-end application, our web user interface, and our generic configurations and structure of our blockchain network. The existing medical record management system has certain serious drawbacks. By this project, we attempted resolving these drawbacks by using private blockchain network modular design approach, scalable network designs, and a very user-friendly interface as you have seen earlier. Thank you.